Thank you for joining us. Welcome to the 18th Annual Borlaug Memorial Lecture. Today, we come together to honor Dr. Borlaug's remarkable contributions to the fight against world hunger and to celebrate those who continue his mission. This event is made possible through the collaboration of the World Food Prize and the College of Food, Agricultural, and Natural Resource Science of the University of Minnesota. The organizing efforts for today were led by Mary Boucher, Bob Super, and 3 student representatives from the 3 departments with which Dr. Borlaug had in class. Forest Resources, where he completed his undergraduate degree, Lab Pathology, where he earned his master's and PhD, and Agronomy and Plant Genetics, where he served as faculty. Please allow us to introduce ourselves as your hosts and the student organizers. My name is Inez, and I'm a PhD student in the Agronomy and Plant Genetics department.
I'm Katrine, and I'm a master's student in the NRSM program, which is Natural Resources Science and Management. It's a part of the Forest Resources department.
Hello, my name is Linda. I'm a PhD student in the program. So we'd like to now welcome Associate Dean Julie Grossman to the stage to share opening remarks for today's special memorial lecture. Dr. Grossman's introduction holds extra meaning today since she received the Emerging Leader in Plant Science Award right here at this event back in 2015. Let's give a warm welcome to Associate Dean Dr. Grossman.
Thanks for inviting me to be here today. So I'm here to welcome you on behalf of the college, so CFANS. And this is, of course, the 18th Annual Borlaug Memorial Lecture. In my mind, this event is really a cornerstone for what we do here in CFANS. It represents our dedication to solving problems related to global food security. And we have 2 guests here today, which we're really incredibly honored to welcome. Both Dr. Vance Whitaker, who is the Ellipse Award winner, and we'll find out more about him soon, and Dr. Swati Nayak, who is here as our distinguished guest speaker. So we're very excited to have you here today. The Borlaug Memorial Lecture, as was mentioned earlier, was established to celebrate both its namesake, Dr. Norman Borlaug, but also to celebrate the countless others who are helping to solve some of our global and really challenging problems related to global food security. Dr. Borlaug, as you know, is well known for his work developing high-yielding wheat varieties that are disease-resistant, work for which he was awarded the Nobel Peace Prize. Later in his career, he founded the World Food Prize, and this was that piece that was going to be honoring other people who are following in his footsteps, so others who are also working to alleviate the hunger and help increase food security globally. The Memorial Lecture, as was mentioned, is a collaboration with the World Food Prize, as well as provided support by the Departments of Agronomy, Plant Genetics, Plant Pathology, and Natural Resources. And it's really an opportunity for us to reflect on Dr. Norman Borlaug's vision and what he did and continues to do through his legacy to solve some of these global challenges. One of my favorite parts about this program, I don't know if you caught this, but it's entirely organized by students. And of course, help with, I should say, Mary Bruschetti as well, who's everywhere all the time. But this is a really nice event, and I always am impressed by the degree to which the students are organized, and organize us as the folks that welcome you to the room. So that's really great. Later in the program, we'll have the privilege of hearing from Dr. Swati Nayak. She has been a powerful advocate for farmer-centered innovations and sustainable practices globally. And so myself, I've worked in Latin America with smallholder farmers for many, many years, and really admire her work, especially her work with women farmers. So I'm super excited to hear her talk today. Her contributions also resonate really deeply with what we're trying to do here in the college, in efforts to support sustainable food systems globally. And I think it'll be a really great fit and hopefully inspiring. I always leave these types of events inspired and thinking about what could I do? What could we do? What could we do? Like in my case, I'm working with graduate students to help promote some of these practices. So thrilled all of you could be here today in person. Welcome to those of you who are online. And I'll hand it over to hear about our award winner.
Thank you so much, Associate Dean Grossman, for the wonderful. As we gather to honor Dr. Borlaug's profound contributions, we are reminded of the lasting mark he left on Minnesota and around the world. In his honor, October 16th is officially recognized in Minnesota as Dr. Norman E. Borlaug Food Prize Day. We have a copy here of this year's proclamation, and it's a very fancy document in very teeny tiny print. And we're grateful to have Commissioner Tom Peterson here today to read this proclamation. Please join me in welcoming him to the stage.
Well, thank you again, Tom Peterson. I always say I have the best job in state government. I get to be Commissioner of Agriculture. It's just a great honor. And one thing I would say that stood out to me, I was just telling Les this earlier, is I get into it and I lead trade missions and go around the world. It is interesting how much the University of Minnesota come up and Dr. Borlaug comes up in his work all around the world, you know, and it's great to accept that and to acknowledge that. But I think that just the groundwork and everything it lays is just so impressive. So thank you to the committee and congratulations to everybody that puts this together. So the great thing I get to do is read proclamations, and Governor's a little busy today. I would say though, having been with him a lot, you'll hear him, and maybe you've heard him during, he'll talk about Dr. Borlaug and his work, and they have a little tussle back and forth between Iowa and Minnesota sometimes about how people claim him, but everybody can claim him because it's great work that he does. So I'm going to read this and do the best I can here. They printed out bigger print for me, which is always good. So, whereas Dr. Ernest Borlaug was born March 25th, 1914 on a farm in Iowa. He received a Bachelor of Science degree in forestry from the University of Minnesota in 1937, and then started work with the U.S. Forestry Service at stations located in Massachusetts and Idaho. He returned to Minnesota and received his bachelor's degree in 1941 and a doctorate in 1942, both in plant pathology from the University of Minnesota. And whereas Dr. Borlaug was a varsity wrestler at the University of Minnesota and helped introduce the sport to high schools throughout Minnesota through exhibition matches, as well as refereeing the Minnesota State High School Wrestling Tournament. For his lifelong advocacy for the sport, he was inducted into the National Minnesota and University of Minnesota, Iowa, and Iowa High School Wrestling Hall of Fame. Sounds amazing. Whereas in 1944, Dr. Borlaug accepted an appointment as a geneticist and plant pathologist to organize and direct the cooperative wheat research and production program in Mexico, where he was immersed in the scientific research and genetics for the next 16 years. He was extremely successful in finding a high-yielding, short-strawed, disease-resistant wheat. Also just amazing, but a lot of words together. Whereas Dr. Borlaug's agricultural research in Mexico improved crop management practices and transformed agriculture production during the 1940s through the 1960s and implemented throughout North America, Asia, and Latin America. And whereas in 1970, in the middle of his career, Dr. Borlaug was awarded the Nobel Peace Prize for his work in agriculture, which resulted in saving hundreds of millions of lives by preventing famine and alleviating hunger and malnutrition. And his work and that of his colleagues was responsible for saving hundreds of millions more in the second half of his career. And whereas when unable to persuade the Nobel Committee to develop a prize just for agriculture, Dr. Borlaug founded and developed the World Food Prize Foundation to annually award a prestigious prize for extraordinary efforts in food security. And whereas Dr. Borlaug was recognized with this nation's highest science and civilian honors, the National Medal of Science, the Congressional Gold Medal, the National Academy of Sciences Public Welfare Medal. And he is the only person in history to have earned these awards, along with the Nobel Peace Prize and the Presidential Medal of Freedom. And whereas Dr. Borlaug dedicated his life to serving humanity until his death at the ripe old age of 95, his legacy will live on as an inspiration to young people, a reminder of the importance of agriculture production, and a model of the significant food plays in ensuring world peace. All right. Now, therefore, I, Tim Walz, Governor of Minnesota, do here proclaim Wednesday, October 16th, as Dr. Norman E. Borlaug World Food Prize Day in the state of Minnesota. Thank you.
Thank you, Commissioner Peterson, for reading that proclamation and highlighting Dr. Borlaug's journey and inspiring achievements. All right, as a part of this event, we want to celebrate up-and-coming leaders in the plant sciences who helped to uphold Dr. Norman Borlaug's legacy of innovation and dedication to solving global challenges through agriculture. Today, we have the privilege of presenting the University of Minnesota's Award for Emerging Leaders in Plant Sciences, which recognizes an outstanding alum for their impactful and groundbreaking research in plant sciences, such as plant breeding, genetics, agronomy, and/or plant pathology, while also demonstrating leadership, social impact, and international influence. This year's recipient is Dr. Vance Whitaker. To introduce him, I'd like to welcome Dr. Stan Huckinson, a professor in the Department of Horticultural Science here at the University of Minnesota. Please join me in welcoming Dr. Stan Huckinson.
Good afternoon. It's my great pleasure to introduce to you Dr. Vance Whitaker. As you can see here, he is an alumni of the university in the APS program. Worked here on his master's and PhD in rose genetics and disease resistance, and then migrated on to work with strawberries. Vance has become a seminal leader in strawberry breeding and genetics. I happened to work with strawberries before I got here, and I can say that back when I was a kid, we utilized a pretty old approach to strawberry breeding, recurrent phenotypic selection. And those of you that know what I'm talking about, you pick the meritorious, the best that you have from your previous year's cross, and use those to create populations. The bigger the populations you can create, the better chance you have success. It might sound really good to you, unlike some of the agronomic crops with these strawberries. Advanced have to go out and feast these things. And it sounds great at first, but it gets pretty old and tired. And last year he had 15,000 seedlings in the field, and you know, I eat strawberries every morning. 5 are great, 100 would be way too many. But what Vance has done is revolutionized strawberry breeding, and he's employed genomic selection and developed markers for some critically important disease resistance, and flavor, root characteristics, and utilize those to do basically what I would refer to as predictive breeding. So they can put out seedlings, and even though maybe they put out 15,000 seedlings, they have upped the odds of having good seedlings to select from. So they don't have to eat lousy strawberries, they eat a lot better strawberries. Critically, back when I was in the strawberry breeding business, if we could turn over a cultivar in 8 years from the time we made cross, that would be really remarkable. Generally, it's more like 12 years. Vance has now gotten the program to the point where they go from cross to cultivar in 4 years, which is really absolutely amazing. So without further ado, I just want to welcome Vance up here, and he can tell you the story better than I can.
Thank you, Stan. Without him, I certainly wouldn't be here. He kindly nominated me for this award. He was a wonderful advisor, and I think his kindness in nominating me is just a extension of who he is and what a great advisor he was. I want to thank the committee. I want to thank the students, Ines, Katrine, and I'm sorry, you want to join? Okay, I wanted to get that as close as I could. Thank you so much for inviting me. It was great to meet you guys today and speak to the students. And thanks for allowing me to have this opportunity. I have limited time, and so what I wanted to focus on today is just a couple stories that I'll just call journeys. Minnesota to Florida was a long way to go. It's pretty different. We do everything backwards down there. We grow things in the wintertime instead of the summertime. We just got through a hurricane. Those are pretty different. But I want to talk about some research journeys, and by that I mean just some long-term projects. I've been there 15 years now. There's some really interesting long-term research that I think has been a lot of fun, and that also, interestingly, has some connections back to Minnesota, and I want to highlight those as well. So I'll call it Minnesota to Florida and other journeys. Now, I know the thing that you're particularly concerned about is this question. Going from Minnesota to Florida, how is the fishing? Could it compare at all to muskie fishing in Florida? And I just want to tell you that we do have really good fishing down there. That's a muskie I caught in November of 2008, and I think this redfish was in the summer of 2011 in Florida. Redfish taste really good, by the way. Come down to Florida, we'll go fishing together, and we'll enjoy it. Now, a little bit about the Florida strawberry industry. As I mentioned, we grow strawberries in the winter, which is quite odd, isn't it? We've bred strawberries to be planted every year in an annualized culture, to have no chilling requirement, to put them in the ground, yield as quickly as possible, and give us supermarket strawberries in December and January. But that sounds a little easier than it is. We do have 14,000 acres now. It's an industry that has grown as berry consumption for human health and enjoyment has grown a lot in the last few years. The program has been going in some form since 1948. I'm the fourth breeder in line in that program, and I'm standing on the shoulders of others. I breed at the Gulf Coast Research and Education Center between Tampa and Plant City, where our industry is concentrated. This is the leading variety in our industry currently. It's called Florida Brilliance. You can probably see why it's named Brilliance. It has a brilliant shine, and it represents a couple of interesting traits in strawberry breeding. Strawberry varieties no longer have the seeds protruding as much on the outside of the fruit. It gives kind of a sandpapery feel in the mouth. That we now breed them to be sunken, and what that does is the curvature of the surface of the fruit in between the seeds and the wax that we breed for gives this great shine because the light refracts in so many directions. Brilliance, we released that in 2017. It's about 60% of the acres in Florida. It yields a lot when we need it to yield. It has good disease resistance package. The fruit are very easy to access and pick. One of the really important things to understand is that in Florida, we plant well over 200 million plants every year, and every one of them is planted by hand. They're bare root plants that are very difficult to find a mechanical solution to plant. Every berry is harvested by hand. So everything related to labor is extremely important in strawberry breeding, and that's why these fruit have to be so easily and quickly accessible, why we want even size. This is Encore on the left. That's a bucket of fruit that I picked in about 30 seconds going down one row. That is a great test for how quickly and easily you can harvest fruit of a very uniform size and shape. Unfortunately, we don't have robots yet, and probably won't for a long time, that can effectively pick strawberries. On the other hand, we have this variety Felicity that was released in 21 that is, you see it there in southern Spain in high tunnel culture. So much higher latitude, a Mediterranean climate that's much cooler, wetter, and cloudier in the winter and under a tunnel. It has to have a different color, a different yield pattern. And so we are thinking about other places around the world. Our strawberry varieties are grown in more than 70 countries around the world, where strawberries are grown in the winter and early spring and around the entire Mediterranean basin to serve mainly the European market is one of those areas. So it's been a lot of fun to work with that market as well. Strawberry is clonally propagated, as I mentioned, well over 200 million plants every year in Florida. It is an allo-octoploid, so the genetics are a lot of fun. We went, though, from, and this is some of our test plots here at the Gulf Coast Center. We went, though, from, in my time, no markers, no maps, no nothing, to today we have all of the chromosome scale phased genome assemblies that we could want. It's been an incredible transformation in tools, science, and technology. And here, just highlighted on these chromosomes, are just a few of the loci that we've discovered in the recent years related to fruit quality and disease resistance. So I was lucky. I came into strawberry breeding at a wonderful time where strawberry breeding could indeed change pretty quickly. The first story that I want to talk about relates to the story of strawberry domestication. And if you're not familiar with this story, this is a very interesting story. So a French spy spying on the Spanish in Chile in the early 1700s brought the octoploid wild species chiloensis back from Chile to Europe. Meanwhile, in the mid-1600s, mainly English explorers, probably in the St. Lawrence River area, brought Fragaria virginiana, another wild octoploid, but a different species, back to Europe. They hybridized in Europe to create the hybrid species we have today, Fragaria X ananassa. And then breeding occurred in Europe. The hybrid species came back to the United States. And then further breeding was done with wild species introgressions to continue to develop what we know as the cultivated strawberry today. So it's a very recent species, domesticated in the last 300 years, that is still incredibly diverse. And there's a lot to learn from looking at the genomics of strawberry, which we've just recently been able to do. This is the work of Jin Fan, Dr. Jin Fan, who is a postdoc in the program currently. So one of the things that we discovered is that while the early hybrids had the purple is virginiana and the red is chiloensis, closer to 50-50, like the early hybrids, modern varieties have very little chiloensis in the genome. It is mostly a Fragaria virginiana genome. And this small green is Fragaria chiloensis subspecies from the west coast of North America, not South America. And so what this taught us is where wild octoploid species are underrepresented in the genome of cultivated strawberry, that is guiding introgression efforts today. So it's not surprising then that we would use some of the very nice accessions of Fragaria chiloensis from the west coast of North America in breeding. And you can see some of those introgressions right here. One of the interesting things that I was able to take advantage is one of those Minnesota connections. So we began breeding with something called FVC 1158, which is a reconstructed Fragaria ananassa that was started by the work of none other than Jim Luby and his former student, Chad Finn, here at University of Minnesota. Other people like Stan was involved in the evaluation of some of this material. And this has lots of that Pacifica subspecies of chiloensis in it. And in this, we discovered that there is a disease resistance locus for something called charcoal rot that is called MP3, which is homologous to a known locus on a different subgenome of the same chromosome. And it turns out this is about 400 different genes, homologous genes across the two subgenomes. And it turns out that the candidate genes that we have are for strengthening cell walls in roots and crowns. This is a root and crown disease. But we wouldn't have had MP3 without these efforts of going back into strawberry domestication and crossing in underrepresented subspecies of the wild material. So that's a very cool story. This is the work of LSR alum who just graduated with her PhD from our program. And if you pyramid the QTLs that we have now, the first, second, and third locus, you can see that that third locus, MP3, reduces the disease quite a lot. Classic QTL pyramiding study, and we're making a lot of disease progress now for this that depended on that work. So that's the first journey in strawberry domestication. Another interesting thing is that there's a lot of evidence that that original chilensis from Chile was a white fruited form. And it turns out that there are a number of white fruited forms of strawberry of different ploidy levels. And it also turns out in a really nice collaborative study that we were privileged to be part of, that they're all based on mutations, different mutations in the same gene. It's called MIB10. It's a transcription factor involved in anthocyanin biosynthesis. So we developed a marker for this. And now when we cross white by red strawberries, they segregate, we can predict their color. And we have started to develop white strawberries that are basically the same size, shape, but different appearance and flavor for red strawberries. And that has created a new market. Most of what we called pine berries before were very tiny fruit that could not be marketed in supermarkets. These are now available in supermarkets from Florida producers during the wintertime. And we hope to move that nationwide very soon. Here's an example of a trial in Spain that we did recently. Because the fruit are like a strawberry in reverse, red seeds and white flesh. They look great in a mixed pack, and these are the kind of things that we can do. We really hope that white strawberries will become the fifth berry, along with red strawberries, blackberries, raspberries, and blueberries in the supermarket. So a lot of fun, and all the varieties are called Pearl. So that's a second journey. Another journey that's taken us about 10 to 12 years is flavor science. We focus a lot on flavor. I think most people are pretty disappointed with the flavor of strawberries from the supermarket. And that's something that we really want to change. But flavor is very, very complex trait that's difficult to breed for. I talked more with the students at lunch about this, and I can't provide as many details here. But there's a lot of complexity. There's human genetic complexity in our taste buds and how we taste, which is why we often taste strawberries by committee in the field. There's also so much chemical diversity in strawberries, well over 100 volatile compounds. And there's a huge network of correlations between those volatiles because there's so many biochemical or biosynthesis connections. That creates another level of complexity. And then also we need to do some kind of sensory studies with either large groups of consumers or trained panels in order to, as objectively as possible, quantify flavor. So what we did is over 10 years, we sampled almost 300 different samples of strawberry that we went through sensory panels and fruit chemistry. And the goal was we would better understand the chemical underpinnings of flavor. And we found some really interesting things. Number one, we found a number of different loci controlling volatiles. This was a lot of fun. These are different volatiles that has come from some of Jen's work across the 28 chromosomes of strawberry. And that's been a lot of fun. This has resulted in markers that we've selected for specific compounds. But how did we decide which compounds we would focus on? So for example, this partial least squares analysis showed the volatiles that were most important for strawberry flavor and the ones that detracted from strawberry flavor. So essentially, a large multi-omic study allowed us to prioritize our breeding targets. And it turns out that if, for example, you try to use sugar and acid data to predict consumer liking, but then you add volatiles, your predictive ability goes up about 25%, not just for consumer liking, but even for sweetness. We think of volatiles as imparting, the strawberry specific flavor, or the raspberry specific flavor, or the blackberry specific flavor. But it turns out volatiles actually make people think that the fruit has more sugar in it when it doesn't. Our brains interact with the volatiles, and how all that works, I don't know, but somehow we think that when certain volatiles are present, we think that there's more sugar in the berry. And so this is a great way to breed for non-sugar sources of sweetness in strawberries. And so we've used that, and it's been a long journey. It's been a 10-year journey, but it's been a lot of fun science. The last thing that I want to talk about is with students. So I took a lot from the APS program here. When I came to Florida, all the plant breeding students were earning their degree in the horticultural science department or the agronomy department or forest resources school. We did not have a cross-departmental program. And it was a privilege for me to be part of a team, primarily with Patricio Munoz, Marcio Resende, where we proposed to the Board of Governors a cross-departmental plant breeding PhD program. It's up and running, and we graduated our first student in August. This is Elisar from our program. And the dean was so happy about the program that she wanted her picture with Elisar. Elisar is famous now. But I used my experience there. My experience here at Minnesota really motivated me to be part of starting this program. And it's been extremely, extremely rewarding to see what it's done for the entire group of plant breeding faculty and for the experience of the students. I saw Tabare earlier today. In 2008, I was part of the group of students with the first Pioneer Symposium here. We've had now the Cortiva Symposium for 10 years in Florida. It's been a great legacy and a great thing to be a part of. At this time, I'm assuming I'm running out of my time. And so I just want to thank you. And if there's any time for questions, I'd be happy to take them. Thank you.
Cool. All right, we have a few minutes for questions. Does anyone have any questions?
I'm reading for chill requirements requirements as well. I have for them in the community.
Yeah, so the goal in Florida, the question was about chill requirements. And in Florida, the goal has been to eliminate chill requirement for both vegetative growth and flowering in strawberry as much as possible, to allow for earlier digging in the nursery, earlier planting, and therefore earlier yield. And so one of the things that we would do, for example, is strawberry, speaking of journeys, strawberry plants are snowbirds. They're grown in Northern California and Southern Canada, and all the plants then come down to Florida. Some chilling is helpful for root development on the transplants, but is no longer necessary in any of these varieties for flowering. Because what we would do is we would create plug plants in our greenhouse in Florida in the middle of the summer, plant them in the field, and only select those that would flower very quickly, basically completely eliminating chill requirement. So that is a very necessary trait for early yielding in Florida. And it's also been very helpful for establishing strawberry industries in other places. So for example, Egypt now has the largest processed strawberry industry in the world. And it's built on 97% Florida varieties with no chill requirement because they can be planted in the desert in September and they can grow throughout the winter and spring. So it turned out that was a very useful development that all my predecessors were working on for decades and decades, and I just continued. And pretty much now there's no chill requirement in our germplasm. And so whenever we're introgressing wild germplasm, though, that becomes an issue. We've got to make some progress back to no chill. So great question about something that I didn't discuss here. So thank you. Thank you. Back in the 60s and 70s, my predecessors were working very hard on something called anthracnose resistance, Calototricum genus fungi of multiple species that basically can completely devastate strawberry production. They can attack any part of the plant, fruit, flower, root, crown, leaf. And that was absolutely necessary to establishing a viable strawberry industry in Florida. So we've continued to try to maintain that resistance. And then right before I came to Florida, methyl bromide was phased out. And so diseases like Phytophthora cactorum, charcoal rot caused by Macrophyllina, Phaseolina, and other diseases became more and more important. And so a lot of our work has been around finding the genes for those original Calototricum resistances, understanding the genetic basis, and then the genetic basis of other root and crown diseases. But just 4 years ago, Florida gets everything new, all the invasive stuff. We got a new strain of a new fungi that attacks every plant part that was never a problem in strawberries before. And it turned out that we had almost no resistance to it. So it became very important to use genomic selection and back crossing and other things to go as quickly as possible for resistance to, in this case, a disease called neopestalotiopsis. So the problem is it's always changing in Florida. The targets are always changing. It's been a huge challenge for disease resistance. Some resistances are very complex. Powdery mildew resistance, no major loci, a great target for genomic selection, for example. So it's really a mix of approaches, and it's like 6 different diseases at the same time. Yes. So Josh, could you raise your hand? This is Josh Sleeper. He's our genomic selection guru in the program right now. Amazing story. Josh was a former student of Rex Bernardo's, as Rex was on my committee too. Josh lives with his family in South St. Paul and works for the University of Florida Strawberry Breeding Program. Connects to the US supercomputer every day, and the statistics and quantitative whiz that he is, he runs that. And so please talk to Josh more afterwards if you have more questions, because he's really the guy. We are trying to move the program faster and faster. So we began mainly with parent selection from already advanced material, but now we are using parents from all levels of the breeding program. Essentially, we can make our predictions before the season starts. We can do some early season evaluation and combine our predictions with our field evaluations to choose parents as quickly as possible, make crosses in January, and have the next cycle for the next fall. So it's strawberry is a great model for fruit crops because it can move so quickly to try to test out some of these methodologies. And we've been routinely applying genomic selection for about 6 years now, in the program, but Josh has really taken us a lot farther, a lot faster in terms of particularly the seedling applications that require lower density marker platforms that he's been working on with companies and service providers. And that's been, a challenging but rewarding, road as well. I didn't get to talk about genomic selection today, but we can talk more about that later at the reception or some other time. So thank you for the question. Thank you again. Appreciate it.
Thank you for the inspiring talk, Dr. Whittaker. Now, I will introduce our keynote speaker today, Dr. Swati Nayak. Dr. Nayak is a scientist and South Asia lead for seed system and product management at the International Rice Research Institute. She's known for her innovative approach to engaging smallholder farmers in demand-driven rice seed system. This includes everything from testing and deploying seeds to ensuring fair access and adoption of climate-resilient and nutritious rice variety. Dr. Nayak was the recipient of the 2023 Norman Ernest Borlaug Award for Field Research and Application. Please join me in welcoming Dr. Nayak.
Hello, everyone. It's great honor to be here in the University of Minnesota. I'd really like to thank all of you for having me here, and congratulations for the Emerging Leader Award in Plant Science. And so I'm a field scientist, and I work very closely with rice breeders and rice breeding team in International Rice Research Institute. I lead the unit called Seed System and Product Management, but I'm not a breeder or geneticist. But my role or my research is around to make sure the improved genotypes, which we are making out of our breeding research and development programs, we ensure that those genotypes are reaching to the end users who need them the most. So making technology accessible, scalable, and adapted is something which our research unit looks after. So innovation in agriculture can change the world, and there is no denial to this very fact. But when it comes to innovations, and it is a very continuous process, and we also need to ensure that whatever we are trying to innovate, that needs a prioritization and targeted development as well as deployment and scaling strategy embedded into the entire process. So as we say, innovation is not only about a tool or a product, it can be the whole process of change. It can be innovation in terms of product, process, policy, or any kind of avenues that we are looking at to bring the desired result of change or the larger impact which we are looking at. Now, I will be giving example most in the case of rice, which is a product which I deal with, rice-based rice, as well as rice-based farming system is a area where I organize my research. And I'm giving you data, I have populated from World Bank report and as well as the Ministry of Agriculture and Farmers Welfare in India, where you can see that research and development expenditure as a percentage of our GDP is almost quite stagnant over the decade or the many years as you see. And then you see like a volatile trends around the agriculture growth rate as well. What we can clearly state without thinking twice is that there is a very strong disconnect between our agriculture investment as well as what we see as a growth. There are various emerging technology in different disciplines. So why only breeding? There could be like natural resource management, conservation agriculture, climate smart agriculture. So there are different domains of discipline where innovations can happen. And this has been studied by Economic Survey of India in 2023 that every 1 Indian rupee invested in agricultural research, there is a payoff of at least 13.85 rupees. And when we look at the context of Asian farmers, not just confining to one country, but other South Asian countries, as well as the Southeast Asian countries, we are talking about small and marginal holders, like, the small holders who have a patch of land, probably less than 1 hectare. And even in that patch of land, you will find the rice farmers who would have like, 3 to 4 parcels of land and will be growing like, 3 to 4 rice varieties. So it is quite diverse and fragmented. And hence, those farmers are resource poor farmers, and most of the rice cultivated areas falls into the rain-fed ecosystem. So hence, we really do not have a controlled irrigation systems. And then amidst the situation, the risk of taking up high investment package of practices is a big risk on the smallholder farmer who doesn't have a risk-bearing capacity because the landholding size is smaller. The return from investment is a questionable thing, and the rice is not a commercial crop. It is a staple food grain crop. Of course, it employs a significant livelihood base of agricultural labor force. But what we have been seeing is that, often these innovations fail to reach to the farmers at the time of when they need it the most, or where it should reach to them. And there remains a lack of convergence across different institutions that comes from different disciplines. And when we think about scaling a technology, often that comes in the national system or public research systems as a afterthought. It comes as a post facto strategies, and where it is not an embedded strategy before we design something which we really aim to reach to the clients or the end users we look at it. Hence, not only the investment in the research, but also the investment in the scaling strategy side is also quite low, to be precise. Now, when I talk about high-yielding varieties in rice, wheat, or any other staple food grains, and we all are familiar about the history of Green Revolution and how the HYVs had, got into the system and the programs. And we all know that, quality seeds can, stand alone as a single standalone low-cost technology can add to, significant productivity value to the farm holding of smallholder farmers. And but there remains a significant challenge when it comes to varietal turnover in case of crops of rice. Now, let me give an example of India. We see around 1,500 high-yielding improved rice varieties which has been developed and registered, released post 1960. But when you go and check the national seed indent data every year, go for last 5 years continuously, you won't find more than 300 or 350 varieties being indented or demanded. So 1,500 minus 300, 330 variety, we don't know what's happening to that 1,000 or 1,200 products already. Out of these 300 products which is indented or showing in the record, you will see like 40 to 50 products are capturing say 80% of the demand share. So further screening. So when you go to the those 50 products, you see that 10 handful of products are probably the mega varieties. So now from 1,500 to this 50 and then to 10, then we see that significant genotypes which were developed through our breeding investment and resources have actually not really got out to the stakeholders who needed or for whom it was actually developed. So if we look from the pure economics perspective, where did all this investment went and why did these varieties perish and what are the questions come into our mind, that where those varieties which were bred or developed for the different ecosystem clients, or markets were not good enough to replace the older varieties, or those are good enough or decent products, but then the stakeholders were not aware or informed about the availability of such a genotype. So in this context, there is no single answer and it coexists. These two challenges coexist. It's not the case that breeders are not able to develop new, better varieties to replace older chicks, but often the awareness level at different value chain actors are very fragmented. So it's not only just farmers. If you go to top 2 small and medium enterprises, seed sector stakeholders, they even don't have an information and where new product seeds and who is the source breeding institution, how to procure the early generation seeds or the breeder seeds for this commercialization of these things. So imagine when this seed companies or the institutions who are supposed to commercialize and scale are not aware about a product, then we can imagine the plight of the end users, the farmers or the producers. How do we expect that they will be aware about the existence of a better product which they can take to replace a 40-year-old variety or something like that? And when I talk about rice, some of the publications which you can refer 5 to 6 years back published. So that was showing that 26 years is the average year for the rice products in many areas in the Asia. And now if you look at some countries who are showing a little gradual progress, but still it is like 15 years, 16 years, 15 to 20 years of age, I would say, the varietal turnovers. And look at the maize, wheat, or even soybean as the major staples for your area. So we are now talking at a turnover age of 5 to 6 years or something like that. So for rice, our more pragmatic goal for the short-term goal has been that how do we reduce that weighted average varietal age to less than 10 years and then go further to in future as the science and the technology and tools are developing and speed breeding is becoming the norm, and then we have to be more proactive to reduce down the average age over there. Now when we want to talk about increasing the varietal turnover, ensure that quality seeds are reaching to the farmers, I spoke about the varietal turnover issue, the average age of the variety, and why we need to replace. But let me also emphasize that in these pockets of smallholder who grows the rice, 50% of the seed sourcing happens through the informal sector. So that means farmers save seeds. So from a scientific definition perspective, we will not even consider it as a seed, but because of those are OPV varieties, so that they are saving the seeds. So there is a 50% of the requirement which is being untapped through the existing distribution or seed scaling channels already. So That may be because the ratio of the dealership network or the villages are very skewed. In Eastern Indian pockets of smallholders, you go that for one dealer, there will be like 20 villages. So 1:20 is the average, scaling ratio, I would say, from dealership network to villages. So if we are expecting rice seed, which is very low cost and also subsidized by the government, a farmer will incur the procurement cost of traveling from the remote village and go to the district headquarters to buy it. The transportation and logistical cost is more than even the seed cost for the farmers. And then hence it is not a very practical and pragmatic way that to convince them to go, and when they're okay to trade off like a 10 to 15% of the yield enhancement what we have been talking about and go for some farm safe seeds. So hence, how do we penetrate deep into the seed distribution channel to capitalize on the informal seed system, which is very important if we really want to ensure that every farmer is having a quality seed and growing quality certified seed every year. So varietal replacement and seed replacement rate, both are critical for a crop like rice. And then one of the issue over here is that when we are talking about this whole benefit not reaching to the client, one of the challenge has been there. What we identified is that we cannot think seed just as an agriculture input. It is something which is also playing a critical role in a very defined market space regulated by different policies and regulatory affairs. And hence it's time that we consider it as also as a product. And hence we create something which is more closer to the industrial pipeline model. For many commercialized crops like maize, hybrids, and etc., this is an evolved model, probably which many progressive countries already have, where private sectors have a very robust industrial pipeline models. But for rice, it is not. It is not there. So most of the breeding programs are specifically has been focusing on single or one or two specific traits for which they wanted to focus upon. So hence we thought of transforming this approach to make it something which is market driven approach. So when we spoke about the market driven approach, we started segmenting or preparing market segments which are the priority demand capturing market segment across the globe. We identified 24 priority market segments, and each market segment was defined not by a single trait, but a plethora of critical, essential, non-negotiable traits, which is needed by the customers or the producers representing those markets. So we identify what is the volume of that market in terms of acreage coverage across the globe, that million hectares or or billion hectares, how much this segment represents. So we prioritize the segments, and then we customized or granulated it up to the country level, because every country would have a different need. Like if I have identified 24 market segments across the globe, but India is representing only nine market segment due to its existing practices, consumer preferences, or the traditional export requirement, or even the ecosystem which prevails in the country. Hence, we granulated it to the country level. And when as a CGIAR institution, IRRI catalyzed as something as a institution mandated to build the national capacity or strengthen the national system, we identified nodal breeders from the local breeding institutions, be it universities, be it our national research centers, to become the partner into this process. And so every segment were attached with a nodal breeder and nodal breeding network partners, along with some scientists at CGIAR level supporting them to ensure that the breeding research and capacity sharing work activities are going hand in hand. And then, this created a pipeline approach where that you have a check, which is your replacement target. It may be a 20 or 30 years variety stubbornly sitting in that particular market segment, but now you are tracking what are the incoming product in that particular market segment, irrespective of the geographies. So what we saw that, a lot of national varietal release committees or seed release committees emphasize often on geographic boundaries in terms of which is the province releasing what. X province is releasing few varieties, Y province is releasing few varieties. X varieties are not listed in the Y's recommendation, or Y's variety is not listed in the X recommendation, but both the states or both the provinces have some overlapping areas and geographies for one market segments. So when we pull the product as per the market segment, we breach the geographic boundaries. There may be possible that one product which was released for X is actually working very well in Y as well. And there is a commercializing institution who want to capitalize as a first mover's advantage to introduce that product also in the zone Y. And we saw several of these cases emerging. And that emerged because we also had a very robust validation system, following a pipeline approach, following a market segmentation approach to position the best of best product. So as you can see, that continuity of research, how it did, like, the product research and development is something based on the design targeted product profile or the blueprint given to the breeders to breed something very much, a right fitment to the segment which we have identified. So hence, when they were breeding as per the blueprint, the next validation as a, the seed system research unit were there, that they segregate and pool these nominations from the breeder every year to do multi-location on-farm testing, following a tricot model, where they try to compare a check variety, which is the replacement target or a market ruling product, and a benchmark variety, which is in between the new and old products, and several new products emerging from different breeders and institutions, but serving a particular segment. So maybe this year I have a 5-6 nomination. Next year I could have another 2-3, and the top 2 will be promoted to the next year for a panel data. And in a cascaded approach, we started to stack the pipeline, which will be positioned and promoted and scaled by the commercializing institutions. These robust data were shared with the seed accelerator networks in terms of like the decision-making bodies in terms of Department of Agriculture or the public seed corporations, and large number of small and medium enterprises. So as I was highlighting, in case of rice, it is very difficult to find large multinational companies operating in the seed market. There are hundreds of small and medium players. And those small and medium players generally don't have R&D facilities. They might have a little decent amount of market intelligence because they do not want to go into the business loss, or they don't want to incur loss, and they will have their market intelligence side intact, but they don't have a R&D. So when they don't have R&D, they do not have a data being maintained and shared among themselves to make a evidence-driven, decision that which product to remove, which product to bring in, which are the geographies or pockets where they think it will click, So hence, these data sharing platforms were created where, the results of on-farm validations were shared with the scaling agents, and these scaling agents were linked back to the breeders for early generation seed partnership to scale. So like in case of rice, the ratio is 1:80:80. That means 1 kg of breeder seed can give to 80 kg of foundation seed, and 1 kg of foundation seed can give to 80 kg of certified or commercially viable seeds. So hence, as the ratio is very high, the strategic linkages become very important in the early stages of. So that's why the faster early generation seed linkage with the breeder based on the data generated was one of our strategy. And then it comes to that how we are making sure that our innovation is meeting the needs of the smallholder farmers, and to ensure that our scaling approaches or our product advancement approaches are socially equitable and as well as inclusive. So all these commercial institutions may have the business incentives, but we also have a social goal to include that the smallest of smallholders are reaching out to it. I can commercialize a product by sharing the data, creating, a joint convening power and creating network approach. But what about those farmers who are not having access to even distribution network or the dealership network? So who is gonna produce seeds for them or sell seeds to them, or, make sure that they are going to grow these seeds? While throughout our research, different interesting questions keep coming, and a significant number of social researchers also work in decoding, these questions, that how they are doing. Some farmers maybe going 3 and 4 rice variety. They are not ready to replace one particular variety, but they're quickly replacing the other varieties. I mean, are we trying to say that the farmer doesn't have, a common sense that why he is not replacing one particular variety and replacing the other varieties? Maybe in those cases, we know that in that segment, our breeders probably have not come up with something remarkable that can really beat the farmer's choice or the variety which they are growing at it. And sometimes even they do like the seeds are not available in the right time, in the right place to make sure that they are adopting. So the supply system sometimes is disrupted. It is not accessible. The spread and the scaling and the slow adoption rates are also, affected by the institutional or extension network that exist in the region, making it that, restricting the pace of adoption. And when we try to decode adoption, we all understand that, in order to create that, the supply and demand system need to work together. So when I create the, it may start with the demand system, that when we generate the awareness and knowledge, but at the same time, availability and access needs to be ensured apart from creating demand to ensure adoption. A lot of traditional public extension systems focus significantly on the awareness part or demand creation efforts. You go and you will find a large number of optimally organized demonstration plots, farmer field schools, knowledge creation efforts, and etc. But what about the supply chain? What about the availability and access? So until and unless you create institutionalized arrangements, so I exit from the scenario as an extension agent, but the farmers don't have seeds to grow. So the next year there will be disadoption immediately. We have given a seed mini kit, they are growing this year, but maybe in a 1 year or after 2 years, there will be disadoption. And in this scenario, and we ensure that availability is not equal to access. Access is like, in the closest proximity when they are having, seeds. So having like a commercializing agency, a licensed seed company is existent in the region or operating in the region doesn't mean that 20 or 30 odd villages are getting the seeds, because we do not have a dealership network nearby to that. And if we comprehensively look after these, 3 A's, adoption is an intermediary outcome which we can see, and that would require also significant behavior change, which we need to take care. And then only when an adoption is sustained, then we see the result of the impact analysis. A lot of these pipeline products and genotypes were bred for impact goals of climate resilience or having a better nutrition. Some of them were biofortified with zinc or high protein or, iron. And then some of them were with 14 days of flood tolerance or salinity tolerance or both flood and drought tolerance. And these are the opportunities of impact, but that can only be envisaged when there is a sustained adoption. So if this intermediary outcome is failed to be achieved, then we probably will not be able to quantify our impact or whatever as a sustainable development goals we comprehensively looking at global institutions. Having said that, when we also create these demand and awareness and etc., so it is very important to become socially inclusive. So some of our models which we have been doing, we are emphasizing significant small yet powerful tools which can ensure that this demand creation efforts are streamlined for the smallholder pockets. On the left side, when you see a cover picture of a training module, that module is like a 15 to 20 page training module, which was exclusively designed with a goal that women are able to follow it and adapt to it. In a traditional household of smallholder, women are the custodians of seed. They select, they clean, they store the seeds historically. And if we are not having a reach of many networks to sell them seeds every year or every season, can they produce their own seeds? And if they want to produce their own seeds, they need to be really skilled in seed production or quality seed production trainings. But some of them are illiterate. Some of them cannot even read or write, the basic, the local literatures and the dialects. So hence, what we try to do is that we design in such a manner that is pictorial, that is more relatable in terms of what they are doing. Even a picture of a farmer has a so-called psychological, implications to it. A lot of government public documents of extension systems, what we develop, it's always like will be male farmers face. Or if we look at the government records and recipients of the training or benefits or subsidies, mostly they are male, but at home, both men and women are involved. So hence we designed many of the structured programs and propagated through national extension system to make sure that it is gender inclusive. Now I'm taking an example of a product brochure or catalog. Like sitting in a very remote area in somewhere in Asia or even in Africa, a small seed company wants to know what new rice varieties has been developed and he wants to grow, where he or she will go, how they will know. And we expecting that breeders and each of these seed companies will talk to each other. We do not have that system yet that, we can rely on that kind of communication, that the researchers will be talking to this commercializing scaling institutions in a, regular basis. Hence, we needed to create some brochure where we had very simplistic one-pager product profiles available in public domain, which can be downloaded, printed, and shared. We created a global market intelligence platform where we started developing, uploading, OPP, which is a one-pager product profile in both English and local language, so that anybody can go and, pull out from that repository, share and use as a decision-making tools. Basic information, very simplistic way we have put into that so that, someone can know that this product is released by this and this center in this year. The seeds can be, early generation seeds can be sourced from here. What is the parentage, where from it is derived, it is coming, what is the producibility or what productivity of that, and what can be the replacement target for this, and what is the companion products for this kind of products, to make some quick marketing decisions, like, what to grow, what to sell, and where to sell. So this OPP is a simplified form. And then we also innovated around digital tools which we call as a seed cast, a seed, primarily focusing on our dealers and small farms. We wanted to create a market intelligence system where they're able to forecast the demands. So right now, the process of demand indenting, which is reflecting in national systems, are cumbersome. Those are paper-based demand indenting. Those are collated every season, every year, and not reliable and also not efficient. Hence, digitizing it would create a more real-time data by which, the dealers dealers can collate their demands and etc. And we can also know that how the trend is changing. Sometimes we rely on historical data and think that, okay, for the last 10 years, this is the priority for the market and probably these are the products which will run. But looking at futuristically, we know that people are looking at different kinds of products, but they are not having access. So Seedcast is one of the tools which, basically to aid stockists, dealers, or the seed companies to give a decision support that what to produce, what are the demand trends, how to digitize, how to do the trend analysis, and etc. So some of these aids were, incorporated into the models. And now when you were talking about 50% of the seed market being, governed by the informal seed system, where farmers are saving their own seeds or sharing among each other. Creating overnight dealership network is something which is a far-fetched dream because it requires a significant investment. But thanks to various social mobilization efforts in many of these countries, we find a lot of significant common interest or joint liability groups of communities and institutions, or whom we call farmer producer organizations or the institution already sitting doing various activities. So can we leverage these farmers institutions to get them into seed as one of the potential economic activity or income generating activity? And we successfully did that. And we saw that several of these institutions, especially led by women and also by male farmers, were potential, entrepreneurs who never got that opportunity to become seed business or run small seed business. So hence, we kind of mobilized and encouraged them to become seed entrepreneurs for the area and capture on the untapped potential of that market already existing in the location. Their social networking is quite strong. as a research organization, scientific organization, we can train them on low-hanging fruits on quality seed production, but they need business skill. They need a knowledge about regulatory affairs, how to clear different stages to become a licensed grower, how to certified label seeds, and etc. So we created that linkage so that they are also having business linked trainings to be able to seed entrepreneurs. And we could see that over the years, they're handling several tons and volumes of quality seeds in through their social networking, lead marketing, and etc. What they needed is more comprehensive knowledge, which was probably not given to them in our traditional extension approaches, which we tried to change. So these are some of the participatory models which we also follow in terms to engage the community and farmers' stake in the entire program of breeding, selecting right product, positioning, and etc. So as you can say that, as we say, this is a aerial view of a crop cafeteria where 15 to 20 products which are comparable are actually grown in a RBD model. And then but what we are here, including that all the stakeholders, including men, women, millers, dealers, they through field day, they do ranking based assessment of what they like and don't like. So we create a segregated trait preferences, not just for men versus women farmers, but also we find preferences for the market actors versus the producers and other critical stakeholders. So that gave a significant decision triggers also to us, what really can work in a region and what cannot work. Sometimes policy can create some avenues which we cannot think through over the years of efforts. I can give an example of India and Bangladesh, where zinc biofortification in rice has been very critical. But we all know, and the breeders know very well, that when we go for micronutrient-based biofortification, there are negative correlation between yield and micronutrients. And through that, when we're trying to check the bioavailability, and we were all aiming for a zinc variety which should be more than 24 ppm to be able to be benefiting human health. India didn't have any variety which was fitting into that bracket, and we could have waited probably for years for that particular variety to arrive. But at the same time, the neighboring countries were already developing that varieties which has 27 or 26.5 ppm of zinc variety and high yielding. That was Bangladesh. So rather than investing another 6-7 years to breed in new varieties, we could see the avenues and leverage a policy called Seeds Without the Border policy, which basically breeds, which basically unify different member countries, where a released product in one country can go to the another member country who are the signatory of this agreement. And we leveraged and ensure that it is disseminating or reaching to the farmers who are having similar ecology, and they are able to grow that variety quickly. So similar exchanges were quickly done, and seeds were made more accessible, which is our goal, that we need to ensure that the innovations are reaching to the smallholders at a faster pace. So apart from the processes which were locally done, policies have done. So these are some of the examples that how through a comprehensive approach of demand creation and localized supply models, we have seen significant adoption rates in our studied area with the smallholder households, where we have organized studies and research to find out how the adoption or the uptake of varieties has been. As you can see, that we also have some of the controlled states and the states where we did not intervene. We have seen that how significantly the weighted average varietal age has reduced over the 5 years from 15 to 7.15. So this is not something which is not achievable. It is achievable provided we create a very integrated and coherent pipeline-driven approach, not just for breeders, but for the extension and scaling stakeholders. It's important that they speak in a similar language. Genetic gain should not be a term only which breeders needs to define. Genetic gain is something which an extension specialist should also able to simply understand that what it means for the farmer or what it means for them to have a business. So creating those uniform understanding and integrating the systems very well and creating that multidisciplinary linkage in our system is very important. We may be individually very strong research programs in very different countries, but when we come together, there are significant silos. As we say that 1 + 1 is not always 2. So that's why, this integration is very important to make sure that seeds are reaching to their end users. So, yeah. So thank you.